Okay, so in this example, I'm going to read to you the problem. Okay, so I'm going to read it slowly, so make sure you write down the information. Here's the picture I drew that represents the window. Okay, so this is about an architect who designs a window. And so I'm going to read you the problem, so make sure you pay attention. Okay, so in this case it says, an architect designs a window in the shape of a rectangle with a semicircle on top, as shown on the board here. The base of the window is 10 centimeters less than the height of the rectangular part. So let me say that again. The base of the window is 10 centimeters less than the height of the rectangular part. Express the perimeter, P, of the window as a function of the radius, R, of the circular part. Okay, so now we want to express P as a function of R. Where P is the perimeter around the window and R is the radius. Okay? Okay, right here. So now, what's the perimeter? The perimeter is the distance around the entire window, which is going to be two pieces. We have these three sides of the rectangle, and then we have the semicircle. So we're going to be dealing with circumference. Okay, so this is the formula for circumference. So actually this is the perimeter right here. So this piece represents the perimeter, or the perimeter of the circle. So half the circumference of the circle. And then we've got this side, and this side. Well, this side here we know is going to be the same as the other side. So guess what? All we have to do is add these up and then simplify, right? So P equals 1/2 times 2 pi r plus 2 times this, right? There's two sides, so we're going to do 2 times 2r plus 10. So I'm going to erase this. Okay, plus 2r. So here's my formula. So now all I have to do is simplify this, right? So I don't want to leave it like this. This is messy. So let's simplify it. So 1/2 times 2 is 1, so that's going to go away. So I get pi r. And then here I'm going to get plus 4r. I'm going to distribute, right? I'm going to distribute to both. So this becomes 4r plus 20 plus 2r. And so now I'm going to add like terms, combine like terms. So I'm going to get what? I'm going to get pi times r plus what? 6r plus 20. And finally, now I've got this r in here, so guess what? I'm going to factor out the r. So I'm going to write this as 6 plus pi times r. So I just factored out the r plus 20. And I'm done. So this is P. Or in other words, I can write it as f of r. Now, here's the domain. Obviously the radius cannot be 0, right? Because if it was 0, we wouldn't have a window. So the radius can't be 0. Okay, it can't be negative. But we really don't know how big the window can be, right? So let's just assume that there's some maximum value, again, based on construction, right? You can't construct a window forever, right? You can't have an infinite window. So what we would do is we'd say the domain for R is going to be obviously greater than 0, but less than or equal to some capital R, where the capital R represents the maximum radius based on construction restrictions and things like that, materials, whatever the case may be. Design considerations. Okay, that's it.